Hydrogen bond. What is hydrogen bond? A hydrogen bonding is an interaction involving a hydrogen atom located between a pair of other atoms having a high affinity for electron. These bonds are weaker than ionic or covalent bonds because it takes less energy to break this type of bond. However, a large number of these bond coions can exert a strong force. Hydrogen bonds are the result of an unequal charge distribution on a molecule. These molecules are said to be polar. If we look at a water molecule, we can see the oxygen atom shares electrons with two different hydrogen atoms. So in total, this molecule has 10 protons, 8 from oxygen and 1 each from the hydrogen atom, and a total of 10 electrons, 2 shared between the oxygen atom and hydrogen atom number 1, and 2 shared between the oxygen atom and hydrogen atom number 2. So it is 4 total share. And the other 6 non-share electrons from the oxygen atom. So this water molecule is electrically neutral, but it has a partial positive side, the hydrogen side, and a partial negative side, the oxygen side of the molecule.
As we know that a hydrogen bond is a special type of dipole-dipole attraction which occurs when a hydrogen atom bonded to a strongly electronegative atom exists in the vicinity of another electronegative atom with a lone pair of electrons. These bonds are generally stronger than ordinary dipole-dipole and dispersion forces, but weaker than covalent bonds and ionic bonds. The strongly electronegative atom includes nitrogen, oxygen, and fluorine. Nitrogen is a non-metallic element of group 15 of the periodic table. It is a colorless, odorless, tasteless gas that is the most plentiful element in Earth's atmosphere and is a constituent of all living matter. Nitrogen atoms are relatively small in size and high in electronegativity. Nitrogen ion formula is N3-. The melting point of nitrogen is negative 209.86 degrees Celsius, while the boiling point is negative 195.8 degrees Celsius. Next atom is fluorine. Fluorine is a very pale yellow-green, dangerously reactive gas. It is the most reactive of all the elements and quickly attacks all metals. Steel wool bursts into flames when exposed to fluorine. The fluorine ion formula is F-. Fluorine melting point is negative 219.67 degrees Celsius, while boiling point is negative 188.67 degrees Celsius. Other atom is oxygen. Oxygen is a non-metallic chemical element of group 16, or the oxygen group of the periodic table. Oxygen is a colorless, odorless, tasteless gas essential to living organisms. Oxygen forms compounds by reaction with practically any other element, as well as by reactions that displace elements from their combinations with each other. In many cases, these processes are accompanied by the evolution of heat and light, and in such cases are called combustions. Its most important compound is water. The large values of the electronegativity and the electron affinity of oxygen are typically of elements that show only non-metallic behavior. The oxygen ion formula is O2-. The melting point of oxygen is negative 218.4 degrees Celsius, while the boiling point is negative 183.0 degrees Celsius.
Two types of hydrogen bonding. Let's see intermolecular hydrogen bonding first. It takes place between different molecules of the same or different compound. The examples of intermolecular hydrogen bonding are water, alcohol, and ammonia. Now let's see intramolecular hydrogen bonding. It takes place in the same molecule. Ortho-hydroxybenzaldehyde, ortho-nitrophenol, and ethylene glycol have intramolecular hydrogen bonding.
The strength of hydrogen bonding depends on type of bond, bond length, and electronegativity. of an element. Hydrogen bonding is weaker compared to intramolecular forces. Examples of intramolecular forces are ionic and covalent bonds. Ionic bonds are formed due to electrostatic attraction between two atoms. Hence, they are definitely the strongest. Next, covalent bond. Because they are formed by overlapping of orbitals of atoms, hence it is stronger than hydrogen bonding. While in the intermolecular forces group, hydrogen bonding is the strongest because hydrogen bonds with very electronegative elements, which is nitrogen, oxygen, and fluorine. While dipole-dipole attraction is not as strong as hydrogen bonding, and London dispersion attraction is the weakest because it is only a temporary bond. According to Coulomb's law, the distance between two electrical charges has reverse effect on power of force between them, which means that the larger the bond length, the weaker the hydrogen bonding. Fluorine is very electronegative element, and so the bonding electrons will be attracted strongly towards the fluorine away from the hydrogen. That leaves the hydrogen with quite a lot of positive charge and fluorine with quite a lot of negative charge. Therefore, hydrogen bonding with fluorine is the strongest, while nitrogen isn't anywhere near as electronegative as fluorine. There will be less positive charge on the hydrogens and less negative charge on the nitrogen. The attractions will therefore be weaker between the positive hydrogen and the lone pairs on the nearby molecules. Lastly is oxygen. Oxygen is the least electronegative elements between these three. Therefore, oxygen will form the weakest bond with hydrogen. First, hydrogen bonds are directional. Directional means that atoms are bent at specific orientation in space relative to another and have definite shapes. For example, water molecules. Atoms in water molecule can only form hydrogen bonds at a specific orientation. If not, the attraction cannot happen. Hydrogen bonds can contribute in boiling points. Hydrogen bonds has lower melting point than ionic and covalent bond because these two bonds are stronger, which means that it is harder to break compared to hydrogen bonds. However, hydrogen bonding have higher melting point than van der Waals dipole-dipole interaction and van der Waals dispersion forces because hydrogen bonding is a lot stronger, which means that hydrogen bonding needs more energy to break the bond.
When we compare the boiling point of nitrogen, oxygen and fluorine, the boiling point of oxygen and fluorine is higher than nitrogen. This is because the atomic mass of nitrogen is lower than oxygen and fluorine. When atomic mass is increased, the boiling point is increased. But when we compare the boiling point of oxygen and fluorine, the higher boiling point is owned by oxygen that has lower atomic mass than fluorine. Why this happen? It is because the fluorine is a special case because of its very high electronegativity makes the electrons more tightly bound, making them less available. So, intermolecular forces are smaller, which makes its boiling point lower than oxygen, although fluorine has greater size of atoms.